What is going on, everyone? So today we are looking at Leetcode number 977. It's a question called squares of a sorted array. And here we're going to be given an integer array nums sorted in non-decreasing order. We're going to return the array of the squares of each number in non-decreasing order. So we have nums -4, -1, 0, 3, 10. And we're going to square all those numbers and then return the sorted version of that. Okay, and then we have some constraints here. We have a follow-up. Squaring each element and sorting the new array is very trivial. Could you find the way to do this in O of n solution using a different approach? All right, so what do we have to do here? So yeah, there is one way we could do this. We could do this the trivial approach, which would be, very quickly, we'll just go ahead. We could just map through this array, square every single number, and then just run n log n sort, and then we would have the result sorted. And yes, that is a way we could do it. The only thing is our time complexity using that would be n log n. Okay, so can we do this in linear time? That's the challenge here. And the answer is yes, we can. We can do this with a two-pointer approach. Okay, so what we want to do is we want to create a result array, an auxiliary result array, that's the same length of our input array. So here at the bottom, I will have our result. Okay, and it's going to be the same size as our input array. So I'll just go ahead and label these indices here, 0, 1, 2, 3, and 4, and 0, 1, 2, 3, and 4. Okay, and so now what we want to do is we want to use two pointers. We want to have this array here, our input array, and we're going to have a left pointer, and we're going to have a right pointer. Okay, we're also going to have a variable which is going to be result index. And we'll set that to the last index of our result array. So it's going to be set at 4. Okay, and so now all we want to do is we want to compare if the squared value of 10 or the squared value of left or right, so of -4, which is going to be 16, which is greater? Okay, so obviously 10 is greater, so what we're going to do is we're going to go ahead and move this right value into our result index, which is going to be 100, and then what we're going to do is we're going to decrement the right. Okay, and now we're going to repeat the same process. We're going to check what value is greater. Is 4 squared greater, or is 3 squared greater? Well, -4 is. Any two minuses that are squared are going to be a positive. So 16 is going to be our next value. So we're going to go ahead and put 16. Also, we're going to decrement this 3. So now our pointer for result index is at 3. We're going to check which one is larger between the left and the right. The left is, so that's going to come here. That's going to be 16. And this left is going to increment. Okay, and then we'll go ahead and decrement our result index. We're going to do the same process. We're going to check which value is greater between left and right when you square them. It's going to be the right, so that's going to be 9. Okay, and we're going to decrement our right pointer. And we'll decrement our right index. Okay, do the same thing. We're going to check which one is greater. It's going to be our left pointer, so this is going to be 1. And we're going to go ahead and decrement this to 0. We're going to increment the left to the right. And then whichever one is greater, they're both the same. So it's just going to go ahead and put in that final value. Okay. And so now we have a result here that is correct. And then we just go ahead and return that result. So now what is our time and space complexity with this problem? Well, we are creating a brand new result array here. So our space is going to be O of n. It's going to be relative to the size of the input. So our space complexity here is going to be O of n because of that result array. And our time complexity, how many times are we iterating over each element dependent on the size of the input array? Only once. We're only hitting each element once. We're not going over it more than once. So it's relative. So our time complexity is going to be linear, O of n. All right? And so let's go ahead and jump into the code. Okay, so what we're going to do here is we are going to first go ahead and instantiate our result array, our auxiliary array. So we can say const result is going to be new array. We're going to set it to the nums.length, and then we can just fill it with 0. So we have some initial value in the array. What do we want to do next? We want to set up our variables. Well, we have a left pointer, we have a right pointer, and we have a result index. So we have 3 variables that we need to set up. Okay, so we can say let left equals 0, let right equals nums.length minus 1, and let result idx equal nums.length minus 1. Okay, and so now what do we want to do? Well, we want to check while left is less than or equal to right. What do we have to do? We have to see which one is bigger. Okay, which value is bigger when we go ahead and square it. So what we can do here is we can say left val is going to equal math.pow our nums at left index to the second power. We can do the same thing for the right. Okay, so now we have our left val and we have our right val. And what do we want to do now? We want to check if the left val is less than the right val, then what do we have to do? Well, then that means our right val is going to go into our result because we want to get the bigger one out of the two. So we can say result at result index is going to equal right val, and then we are going to decrement our right index. We're going to also decrement our result index. Okay, else what do we want to do? Well, then we want to go ahead and set our result at result index to the left val. And we want to increment our left. What we could do here is just remove this so we don't have a duplicate. And then set this here. We can say our result decrements. Okay, and now we just go ahead and return our result. Let's go ahead and run that. and we're good. Okay, so that is Leetcode 977, squares of a sorted array. We want to use a two-pointer approach on solving this. It's not that bad if we just make clear, very clear, what our variables are, our left, our right, and how we're stepping through all of this. Okay, so that is squares of a sorted array. I hope you enjoyed it, and I will see you guys on the next one.